Now let's solve the maximum depth of a binary tree. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So in this example, the maximum depth would be 3 if you go from this root all the way to this leaf node, or from this root to this leaf node. That would be 1, 2, 3, or 1, 2, 3. Okay, so what we want to find is how many nodes we need to pass through from the root to the deepest leaf. A tree with one root, so just one node, would have a depth of 1. Now, for any given node on the tree, its depth would be 1 itself, plus the larger depth of its left or right subtree. Our base case, since this is a tree problem and tree problems usually require us to solve them through recursion, our base case would be we're going to traverse recursively through the left and right subtrees until we reach a null node. Once we reach a null node, we're going to return 0 because an empty tree has a depth of 0. Now, our recursive case would be the fact that we need to compute the depth of the left child and the depth of the right child, and we need to take the max of these two values and add 1 to it to account for the node itself. So, for example, we would start here with 3. We're going to create a helper method which does these recursive calls for us. We're going to check our base case. So is 3 null? No, it's not. Then we're going to store in 2 int variables. We'll call them left and right. The recursive call, the result of the recursive call of our helper method for the left and right children. And then finally what we're going to do is we're going to return 1 plus the maximum depth between the left and right children. So let's see what that looks like. So here we're just going to return the result of the helper method which we're going to create. Let's call it find depth, which takes root as a parameter. Then we actually need to create the helper method. So public, it should return int find depth. That takes a tree node. Then we're going to check our base case. So if node is equal to null, then return 0. Otherwise, int left is equal to find depth of node.left, and int right is equal to find depth of node.right, and then finally return 1 plus math.max of the left tree and the right tree. So let's submit and see if it works. Alright, fantastic. So let's go through this example real quick to see if our code makes sense. Return find depth of root, so that would be return find depth of 3. We're going to call our helper method, and here we're going to check is 3 null? No, it's not, so we don't return 0. Then int left would be equal to find depth of 9, and right would be equal to find depth of 20, and we need to return 1 plus math.max between left and right. So let's take a look at find depth at 9. Is 9 null? No, it's not. So left is equal to find depth of null, and right would be equal to find depth of null, and we need to return 1 plus math.max of left and right. So if we were to call this method find depth and input null, we're gonna get 0, so we can just replace left and right with 0. So this is 0 and this is 0. So we need to return 1 plus math.max between 0 and 0. What's the max between 0 and 0? Doesn't matter, that's 0. And so 1 plus 0, that's 1. So find depth of 9, which is left here, is now equal to 1. And we can delete all this. Okay, so now let's find depth of 20. Is 20 null? No, it's not. So left would be equal to find depth of 15. And right would be equal to find depth of 7, and we need to return 1 plus math dot max of left and right. So find depth of 15. Is 15 null? No, so left would be equal to find depth of null, and right would be equal to find depth of null, and we need to return math dot max of left and right. So once again, if we call this method, null is equal to null, so we need to return 0, and this as well is going to be 0. And we need to return the max of 1, or 1 plus the max of left and right, which is 0 and 0, which is 0. So 1 plus 0, that's 1. So find depth of 15 is 1. And similarly, if you go through 7, you're also going to get the same result, which is 1. And we need to return 1 plus math.max of 1 and 1, so it doesn't matter, that's 1. 1 plus 1, that's 2. So find depth of 20 is equal to 2. And then finally, we need to return 1 plus math.max between 1 and 2. So the max is 2. And then add 1 to it, we'd get 3. So the maximum depth of this binary tree is 3, and that makes sense because 1, 2, 3, or 1, 2, and 3. So that was the maximum depth of binary tree problem on LeetCode. I hope you found that video helpful, and thanks for watching.